All right, in this example, we're being asked again to draw the products of the following acid-base reactions below. And then we're going to label each compound as the acid, the base, the conjugate acid, or the conjugate base. And then we're going to determine the direction of the equilibrium here. All right, so in the last three examples, A through C, for this same question, it was very clear which one was acting as the base and which one was acting as the acid. In the previous examples, we can find where the negative charge was. This example is a little bit different because we don't actually have a species in here with negative charge. What we do have is we have a species with positive charge, right? So we have to figure out what's going to act as the base here. So anything with lone pairs can really act as the base. So it could be the nitrogen, could be this oxygen, but we have to figure out which one is actually going to act as the base. So what do bases do? Bases are going to send their electrons out to grab a proton. And when they do that, the atom that is sending that electron out is going to end up with a unit of positive charge. So for this one, we really have to evaluate, is the nitrogen going to grab a proton or is the oxygen? If the oxygen grabbed the proton from nitrogen here, which it's not going to do, the oxygen would end up with a 2+ charge. So it's not going to be the oxygen, and that should make sense. Oxygen's positively charged here. Think of it like this. The positive charge is hanging on to the negative charge of the electrons. So oxygen isn't going to let those electrons act as a base here. It's really hanging on to them. So that means nitrogen is the thing that is actually going to grab a proton here. So the question is, well, we'll label these first. That's our base, and this is our acid. All right, so on the acid, which protons are more acidic? The ones on carbon or the ones on oxygen? As we're kind of picking up here, it's typically going to be the ones on oxygen over the ones on the carbon. But this is not an alcohol. This is a protonated alcohol, so it doesn't have a pK of about 18. I don't know what the pK of these protons are exactly, but I do know they're more acidic than the protons of a typical neutral alcohol. And that's because it's actually going to be much more stable because it's creating a neutral molecule. So here's what I mean. The base is going to grab a proton from the oxygen. The two electrons get left behind on oxygen. Remember, one belongs to oxygen, the other belongs to hydrogen. But it's going to keep both of them. So we're going to end up forming NH4 because it picked up a proton, so the nitrogen is going to end up with a positive charge, plus the conjugate base of this acid, which is just neutral methanol. All right? So on this side, this is the conjugate base, and this is the conjugate acid. All right? So we figured out what the products are. Now we're going to figure out what the direction of the equilibrium is. And again, for this example, I don't really know the pKs of all these things. I know the pK of ammonia and I know the pK of the methanol on the right, but for these things here, I don't quite really know the pKs off the top of my head, but that's okay. I don't need to know that because we can observe the different stability here by sort of evaluating this and which one's more stable. All right, so let's look at these two species here. Okay, they both have a unit of positive charge. One has a unit of positive charge on the nitrogen, and the other has that unit of positive charge on the oxygen. So we're going to figure out which one's more stable here, positive charge on nitrogen or oxygen. Oxygen's more electronegative than nitrogen. That means typically oxygen handles negative charge better, which means when something's more electronegative, it handles positive charge very poorly. So in this case, oxygen is handling this positive charge worse than nitrogen is. So this thing is more stable with that positive charge. That means the direction of this equilibrium is going to go towards the protonated ammonium ion there because it handles that positive charge better.